Hello viewers, in our today's session we are going to discuss about solving our differential equation here using the Laplace transform. And I think this is one of the most easiest differential equation that we can solve using the Laplace transform. Let us now get into our working, whereby we understand that in our first step we are going to have to come and introduce the Laplace transform to the term of dy square with respect to dx square. We add to 5 the Laplace transform of dy with respect to dx. We subtract from 3 the Laplace transform of y is equals to, here we are going to have the Laplace transform of 0. We understand that this is our first step, whereby we just introduce the Laplace transform to each and every function. From this point, there is a fundamental concept that you need to understand. The Laplace transform of dy squared with respect to dx, the Laplace transform of dy with respect to dx, of which if you check on the introduction part of this video, you will find that I've discussed much on how you can go about the Laplace of dy squared with respect to dx. To mean that now I'm going to have 2 into, we are going to have s square y bar, we subtract from s y naught, we subtract from y1. To mean that when you check out this form, it kind of takes the form of a second order linear equation. We come and add to 5 the Laplace transform of dy with respect to ds. We are going to have, we multiply by s y bar, we subtract from y naught, we subtract from 3 the Laplace transform of y is equals to y bar. And here now the Laplace transform of 0 is equals to a 0. At this point now we need to replace the conditions for the y0 and y1. When you come here, you will find that our y will always take the y0, and here dy with respect to dx is equals to the y1. That is the most important part that you need to understand. Do not confuse the two, whereby your dy with respect to dx, you take it to be a y0. So when I replace the condition, I'm going to have 2 into s square y bar, I subtract from s, y0 is equals to 4. We subtract from the y1, which is equals to 9. We add to 5 into s y bar. We subtract from, here we are going to have 4. We subtract from 3 into y bar, and everything is equals to 0. Now we can open the bracket by, in our first bracket here we are going to have, by multiplying by 2, to mean we are going to have 2s square y bar. We subtract from, here we are going to have 8s, because here we are having 4, and here we are going to subtract from 18. We add to 5s y bar. We come and subtract from, here we are going to have a negative of 20. We subtract from 3 y bar, and everything is going to be equals to 0. At this point now we need to collect, from this point now we need to collect the terms of y bar. When it comes to the term of y bar, I can come and factor out y bar into 2s square. I add to 5s because it has got a term of y bar. I subtract from 3. Here now we come and collect the like terms, a negative, and the term of s we are only having a negative of 8. To mean that we are going to have a negative of 8s. Here we are going to have a negative of 38. Everything is equals to 0. We can make these two cross the equal sign to mean that now we are going to have y bar into 2s squared. We add to 5s. We subtract from 3. Everything is going to be equals to 8s. We add to 38. At this point now, we need to have the term of y bar on our left hand side alone. To mean that we are going to have y bar into 2s squared. We add to 5s. We subtract from 3. Everything is going to be equals to 8s. We add to 38. Here we come and divide by 2s squared. We add to 5s. We subtract from 3. And on this side we are going to have 2s squared. We add to 5s. We subtract from 3. Our y bar is going to be equals to, here we are going to have 8s. We add to 38. Everything is going to be all over 2s squared. We add to 5s. We subtract from 3. At this point, we understand that the Laplace, we say that the Laplace transform of y is equals to y bar. To mean that if we want to move from this point back to our term of y, we must come and say the inverse Laplace transform of y bar is going to be equals to y. When you check here, we need to work out for the function of y. To mean that when we introduce the inverse Laplace transform of y bar on this side, we must also come and introduce the inverse Laplace transform. Now we are going to have y is equals to, at this point we are going to have the inverse Laplace transform of 8s. We add to 38. Everything is going to be all over 2s squared. We add to 5s. We subtract from 3. We need to simplify our denominator, and by simplification of our denominator here, we are going to use factorization. When it comes to the factorization, now we are going to have 2s squared. We add to 5s. We subtract from 3. Products, we are going to have a negative of 6. Sum, we are going to have a positive of 5. On our factors, two numbers that when we multiply them, we are going to have a negative of 6. When we add them, we are going to have a positive of 5. Here we can come and have 6 and a negative 1. When you multiply the two, you are going to end up with this. When you add the two, you must end up with 5. To mean that now we are going to have 2s squared. We add to 6s. We subtract from s. We subtract from 3. Come and group the two. In our first bracket here, we are going to have a common factor of 2s into, here we are going to have s. We add to 3. We subtract from 1. The negative outside the bracket is going to affect whatever we are having within the bracket, and we are going to have s, we add to 3. From this point now, we can come and have our factors as 2s, we subtract from 1, into s, we add to 3. To mean that now, on our denominator here, we are going to have 2s, we subtract from 1, into s, we add to 3, of which we've simplified using factorization. We are going to have y is equals to the inverse Laplace transform of 8s, we add to 38 all over 2s, we subtract from 1, into s, we add to 3. By using partial fraction, everything is going to be equals to the inverse Laplace transform of a all over 2s, we subtract from 1, we add to b all over s, we add to 3. So at this point now, we need to find the value of a and the value of b using the partial fraction. For us to have the value of a and the value of b, we must now use the cover-up rule. By the cover-up rule in partial fractions, this is what I mean. When it comes to the cover-up rule, for the term of a, I'm going to take a, and now we are going to take 2s, we subtract from 1, everything is equals to 0, to mean that 2s is equals to 1. The value of s now is equals to a half. We come and say limit to the term of s approaching a half into, we are going to have 8s, we add to 38 all over, we cover up our term of a, and now we will be having s, we add to 3. We understand that it is the limit to the term of s approaching a half. To mean that now we are going to have 8 into 1 all over 2. We add to 38 all over a half. We add to 3. Here we are going to have 4. 4, when we add to 38, we are going to have 42 all over. Here we are going to have 7 all over 2 when we simplify our fraction here. When you work out these two, we are going to have 42 all over 1, we multiply by 2 all over 7, to mean that we are going to have our value of a now is going to be equals to, from this point we are going to have 12. Our value of a is equals to 12 when we simplify our fraction here. Let us now have the value of b. We understand that s, when we add to 3, is equals to 0, to mean that s is equals to a negative of 3. Limit, still using the cover-up rule, to the term of s approaching a negative of 3 into 8s, we add to 38 all over. We come and cover up our term of b, to mean that now we are going to have 2 s we subtract from 1 is going to be equals to 8 to the term of s is equals to negative 3. We add to 38 all over 2 negative of 3 we subtract from 1. Here now we are going to have a negative of 24 we add to 38 all over a negative of 6. On our denominator we are going to have a negative of 7. On our numerator now we will be having 14 all over a negative of 7, to mean that now here we are going to have a negative of 2. The value of b now is equals to a negative of 2. We have now our values of a and b. After getting the values of a and b, we come and replace them on our partial fraction. And this is now what we are going to have. We understand that the inverse Laplace transform of our function here is equals to the inverse Laplace transform of our function here. To mean that we are going to have 1 is going to be equals to the inverse Laplace transform of a all over 2s we subtract from 1 we add to b all over s we add to 3. But our values of a is equals to 12, the inverse Laplace transform 12 all over 2s we subtract from 1 we come and subtract from 2 all over the value of b s plus 3. To mean that now we need to find the Laplace transform of the inverse Laplace transform of our first function here and the inverse Laplace transform of our second function there. Here now we are going to have 12, the inverse Laplace transform of, because everything is equals to y, the inverse Laplace transform of 1 all over 2s we subtract from 1, we come and subtract from 2 the inverse Laplace transform of 1 all over s plus 3. We will find that whatever we are having at this point matches the Laplace transform of our exponential. Positive or negative at is equals to 1 all over s negative or positive of a. We will find that whatever we are having here on the denominator matches our function here. And now we are moving from this point back into our answer, the initial point. When you check our first term here, you will find that s does not have a coefficient, to mean that we must do away with our 2 at this point. For us to do away with these 2, we can come and factor out our term of 2 on the denominator. When we factor out our term of 2, it means that we take everything and multiply by, we take everything and here we divide by 2, we divide by 2. To mean that we can come and have a common factor on our denominator here of 2. This one will cancel out, and this is what we are going to have at this point. To mean that here we are now going to have 6. When you check at our form here on the denominator here, whatever we are having here kind of matches whatever we are having at this point. Here we do not have any problem. To mean that now we can get the inverse Laplace transform of our function directly. Now we can come and say y is equals to, we are going to have 6 exponential, our value of a at this point is equals to a negative of a. to mean that when it comes to the exponential, the coefficient of t at this point, when we are having here a negative, at this point we are going to have a positive of a half t. We come and subtract from 2. The Laplace transform of the inverse Laplace transform of our function here is equals to exponential. We are going to have a negative of 3t. This is now the Laplace transform of our differential equation that we were having when we started our working. Thank you. Let us now meet in my next session, whereby we are still going to discuss much on differential equation and how to solve them using the Laplace transform.